In this lesson, we're going to learn about C-axis milling. After completing this lesson, you'll be able to create a 2D adaptive toolpath with live tooling. In Fusion 360, we want to carry on with our C-axis drilling example. We've already drilled and tapped the quarter 20 holes around the part, and now we're going to take a look at these pockets. Whenever we're dealing with C-axis operations, of course, your machine has to support this capability. It has to have live tooling, and it has to have the tool changer be able to move specifically off axis of the axis of rotation. So based on that, you might determine a specific strategy when you're approaching a C-axis operation. In our case, I'm going to be focusing on one pocket with the same tool to both rough and finish, and then I'm going to pattern that around the part. So in order to do this, I'm going to have to move on to my milling toolpaths. The milling toolpaths are going to be based on the coordinate system that we have set up in our turning operations. But I'm going to go into 2D, and I'm going to use 2D adaptive clearing. I'm going to select the quarter-inch end mill that's inside of this document. And then for my geometry, I'm going to select one of these pockets. Because we're dealing with a 2D operation, it's automatically categorizing it as an open chain. I'm going to make sure that my heights look okay. It's going to the selected contour. And then I'm going to leave a small amount of stock in the radial direction, but not in the axial direction. I don't want to have to come in and use a pocket operation to finish the floor. I'm only going to come back with a 2D contour to finish the wall. From here, I'm going to say OK. Allow it to come in and clear out that section. And then I'm going to go to a 2D contour, and I'm going to finish off that pocket. Going to make sure in the passes section that I'm not leaving any material, so stock to leave is not turned on. And then we want to talk about ways in which we can extend our selected contour. So the tangential extension distance, I'm going to set to 0.125, which is the radius of my tool, and I'm going to say OK. So this allows me to come in and clear out that pocket. Now I'm going to select both of these inside of the browser. I'm going to go to Setup, and I'm going to create a new pattern. The pattern type is going to be circular. We're going to be going around the center of our part. That's the axis of rotation. And then we need to determine the number of instances that we have. In this case, it's going to be 6. These are equal spacing, but again, if we had sort of an odd number of instances, we could change that to make sure that it's not equal spacing. The next thing that we want to make sure that we do is we keep the original toolpath, which is going to be this first pocket, and we're going to order by tool, which in this instance, it's the same tool. It won't really matter. We can order by operation, or we can preserve the order. So if we want to both rough and finish each pocket before removing, because we are using the same tool, we would want to select preserve order. On the post process, if we had to override the WCS for some reason, we could do that. But in this instance, it's not going to be applicable. Now that we have this created, we want to go into simulate, which will allow us to see the quarter 20 holes drilled and tapped. And then we can come in and we can see the adaptive clearing and then the 2D contour cleaning that out, moving to each other position. We could also do this with another type of toolpath, for example, a 2D pocket, something that would let us both rough and finish it without retracting the tool. But really, it depends on your geometry. This is a very specific example, and the type of geometry is going to dictate which toolpath you use. So again, it's important to understand that when we're doing turning, the functionality of the specific machine must be kept in mind. In this instance, we're talking about C-axis drilling and milling, which means that we have live tooling. The tool changer can move and it can position the tool and the spindle based on our selections. Now, if you don't have this capability, what's going to happen is the post is just not going to work on your machine. So make sure that you don't create tool paths that are outside of the capability of your specific machine. From here, it's always a good idea to save often, so let's make sure that we save this before moving on.